My name is Sunaina, and in today's video we are going to speak about estimation and approximation, and along with that we are also going to solve a few questions of the same topic. Without wasting any time, let's begin. Estimation and approximation from New Syllabus Mathematics, Syllabus D, Book 1, Chapter 3. The first thing in estimation and approximation is rounding off. Rounding off means a number is made simpler by keeping its value intact but closer to the next number. It's done for whole numbers and for decimals at various places of hundreds, tens, tenths, etc. We have rules that we need to follow in order to round off numbers. We find the place value and circle the digit. Example, if you're rounding off to the nearest tens, you circle the tens digit. In this case, it's 5. Moving to the right of the circled number and underlining that digit. In this case, the number is 7, so we underline the number 7. If the number after the circled one is a 0 to 4, then the circled digit stays the same. However, if the number is not 0 to 4 and it's something between 5 to 9, we add 1 to the circled digit. In this case, the number was a 7, hence we add 1 to the previous digit, which is the circled digit, and we make it a 6. Once you've done, the number underlined becomes the 0. So now you can see that 1257 rounded off becomes 1260. While rounding off in decimals, again the rules are the same. All the digits in front stays the same. All the digits behind zeros the name, which means that in this case, if you can see, we are rounding off 1.362 to the nearest hundredths. Hence, we underline the hundredth, which was the 6th digit. The 2 is to decide whether the 6 gets a 1 or not. As the 2 is less than 5, it cannot give a plus 1 to the 6. Hence, it itself becomes a 0, and that's it. In the second one, 25.378 was being rounded off to the nearest tenths. 25.378. You circle the 7 and you decide whether the 7 can give a plus 1 to the 3 or not. In this case, obviously it can, because 7 is more than 5 or 5. So yeah, 25.4 is my answer. The last two numbers become 0, and you need to write the zeros or not is again your choice. Significant figures. Significant figures are used to reflect the degree of accuracy. A number is more accurate when it is given to a greater number of significant figures. We have 5 rules for significant figures. There are 2 figures. I would suggest you to please go through all of them. In the yellow box, the first one says all non-zero digits and any zeros contained between non-zero digits count. For suppose 3000442 is a 6 significant digit. Then in the second one it says leading zeros don't count, which means 0.000034 is a 2 significant figure because the zeros before 3 and 4 are not significant. Trailing zeros count if there is a decimal point, which means 0.00002500 is a 4 significant figure, and here we are counting the last 2 zeros as significant and ignoring the first 4 zeros as they have no significance. In whole numbers, trailing zeros may or may not be counted if there is no decimal point. So we go with the most conservative answer. 190000 is a 2 significant digit, and it can also go up to a 6 significant digit. The same thing is explained in another manner in the white box. Significant figures can be done using a set of around 5 rules with a lot of complications for how to deal with zeros. The first 0 is a non-significant 0 for cosmetic purpose. Then we have the 2 more zeros before the 4. Again, not significant, zeros used only to locate the decimal point. Then this 4 is significant. As you can see, all non-zero integers are significant. After that, there are 2 zeros in the middle. Again, they are also significant because they're between the 2 non-zero digits, hence significant. The last two zeros are also significant because it is a decimal number. If it would have been a whole number, then the last two zeros might have been or might not have been significant according to the accuracy required. All right. After this, we have a few examples where we are going to round off certain numbers to significant figures. To 1 significant, 2 significant, and 3 significant. We have this list of numbers. I would suggest you to pause the video for a couple of seconds and then I will be sharing answers for these. Rounding off to 1 significant figures. Let's have the answers. Compare your answers and see where you stand. Final and the last one to 3 significant figures. Now you can see the numbers and the answers can vary so much when rounded off to different significant figures. Alright, let's move on to a few questions that I'm going to solve. This is review exercise of the same chapter. We have 8 questions in this review exercise and I am going to solve all 8 questions for you. Again, without wasting any time, let's start. Alright, so this is question number 1 of the review exercise where it says round off 6479.952 to the nearest hundreds. So let's write down the number. The number is 6479.952 and we are rounding off to the nearest hundreds. Hundreds means units, tens and hundreds. So this is the digit that I'm rounding off to. After this is a 7. The 7 decides whether to give a 1 or not. As 7 is more than 5, it is going to give a plus 1. Hence the number becomes 6500. Right? There we go with the answer. Part A. Then we have part B, which says round off this number 6479.952 to the nearest thousands. And now this is the digit I'm rounding off to. The 4 decides to give a plus 1 or not. The 4 cannot give a plus 1. Hence, the 6 remains the 6. And the rest 3 numbers will become zeros. There we go. Part C, we have to round it off to the nearest tenth. Again, let's write down the number 6479.952. And we're rounding off to the nearest tenth. So this means this is the digit. If the 5 gives a plus 1, the 9 becomes a 10. Again, we cannot write 10, hence it gives a plus 1 here, making this 9 a 10. Again, we cannot write it down. We shift it over here, so our number becomes 6480.0. That's what my answers are. I hope you don't have any more confusions in this question. Let's move on to question number 2. Alright, the question says express 4.793 and 39.51 correct to 2 significant figures. So this is my part 1. Here I have to round off 4.793 and the number 39.51 to the 2 significant figures. The first one for 2 significant figures means 4.7. 2 numbers are significant. The 9 has to give a plus 1, hence becomes 4.8. And the other one, rounded off to 4 significant figures, means these 2 numbers. The 5 gives a plus 1, rounding off, becomes a 40. So there we go. The part 2 says you need to use the answers from the first one to estimate the answer of 4.793 divided by a 39.51. When we rounded off the both numbers, we got a 4.8 divided by a 40. Well, if I am to solve this number, I'm going to write 4.8 upon a 40, move the decimal ahead and give it a 0, make it a 48 over 400, simplify it, make it a 24 upon 200, and then a 12 upon 50, 3 upon 25, and I will finally get my answer, which is going to be a decimal number 0.12. There we go. All right. Now we have question number 3. Okay. Review exercise question number 3. The mass of a chocolate truffle is 0.025 kgs. Correct to two significant figures. Okay, so this means the number has already been rounded off to two significant figures. So this means it was not a two significant figure. It was a certain digit ahead. We don't know how many. Okay, what is the smallest possible mass of the chocolate truffle? Okay. To round it off to two significant figures, this means this wasn't a 2.5, it was maybe a 2.4. And if after 2.4 we had a 1, a 2, a 3, and a 4, it would never have been able to give a plus 1. Hence, it was a 2.45, which can give a plus 1. It could have been a 6, it could have been a 7, an 8, and a 9. But as the question wants me to figure out the smallest possible, I'm going to stick on with this answer, and 0.0245 was the smallest possible mass of the chocolate truffle. Do not forget to add the kg. Units carry marks. Question number 4. The question says, a toy cost 35,000 Indonesian rupees. The conversion rate is rupee 1,000 is to $0.145598. Without using a calculator, estimate the price of the toy in dollars. Okay, so to round off this one, we know the two things that we are comparing are the rupees and the dollars. I would suggest you to start using this method if you still haven't, because that's the easiest. We already have the conversion rate, which is 1,000 is to, okay, so the number was 0.145598. To make it easy, how about this 5 gives a plus 1 and make it a 0.15. Round it off. We already know how many rupees do we have. We have 35,000 rupees, which are to be rounded off. Make it an x. Cross multiplication, there we go. 1,000 multiplied by x will be equals to 0.15 multiplied by 35,000. Now, rather than multiplying first, I would suggest you to write 0.15 multiplied by 35,000 and dividing the entire thing by the 1,000, making your life easy. Cancel the 3 zeros, cancel the 3 zeros. You are left with 0.15 multiplied by 35, giving you your final answer. Do some rough work and find your answer. The final answer is going to be 5.25. Hence, we can say that the answer in dollars is going to be 5.25. There we go. Okay, let's move on to question number 5. Here we have the mass of 1 kg sugar, 1 bottle of cooking oil, and 1 box of baking powder, which is 109 grams. Okay, 148.84. It says round off without doing a calculation of total. Okay, perfect. Not very difficult. So we have one packet of sugar. We have one bottle of oil. We have one box of baking powder. Mass is 109 grams. This one is 148 grams. And this one is 84 grams. We need to estimate these. So can 109 also be written as 100 grams? Rounding off this, we get 150 grams. And rounding off this one, we get 80 grams. We need the total mass for 3 packets of sugar, which means we are going to multiply 3 with the 100 grams, giving me 300 grams. After this, we have one bottle of oil, which is 150 grams. Hence, the 2 bottles of oil will be weighing 2 multiplied by 150 grams, again giving me 300 grams. Finally, 5 boxes of the baking powder, each for 80 grams, means 5 multiplied by 80 is giving me 400 grams. The total of these means add the 300, 300 and 400, giving you a final answer which is 1000 grams, also known as 1 kilogram. It's not as difficult, is it? Question number 6. A battery operated device needs to function for 28.2 hours. It functions for an average of 4.03 hours on one battery. Write down a calculation you could do mentally to estimate the number of batteries required. Okay, make life easy, round it off. 28.2 can be rounded off to 28. Easy peasy. 4.03 can be rounded off to 4. Now, if one battery can work for 4 hours, how many batteries do we need if we need to work for 28 hours? Okay, so 28 divided by 4 will give me 7 batteries. And that is it. This one was very easy. Let's move on to the second one. Seventh one now. Okay. The question says that store A is selling a 500 GB card disk for 85.05 with a 20% discount, while store B is selling the same hard disk for $76.05 with a 10% discount. Write down a calculation you could do mentally to help you decide. Okay, so see, in this case, we need to compare 2 things. One is store A and the other one is store B. I suggest make a line in the middle and start comparing. The first one is giving you a 20% discount, which means you have to pay the 80% of the amount. 80% of 85.05. We are going to round it off and make it 80 over 100 multiplied by 85 in this case. And for the second one, as it is giving you a 10% discount, you have to pay the 90% of the amount. So 90% multiplied by 76.05. Again, rounding off, 90 over 100 multiplied by 76. Do some maths and simplify these to find the final answers. The first one is going to give you $68. The second one is giving you $68.4. I'm sure you all have got your answer by now that the store A is giving you a better choice. Okay, so store A, we need to go and buy a hard disk from this one. The last question of this exercise is question number 8. Without using a calculator, decide which one of the option is better value for money. Option A is giving you 250 ml of hand lotion for 15.20. Okay, and the other one is option B, which is giving you 250 ml plus the 50 ml for 17.45. Okay, so for the first one, again, I'll make a line in the middle. For the first one, the 250 ml is for $15.20. When you round this off, we can easily say that it is $15. If 250 ml is for $15, then is 50 ml for $3? Right, we divide both the numbers by 5. Okay, hence in the second one we have 300 ml in total. We need to find out how much is the price for these in 300 ml. So 300 ml would cost me, this is being multiplied by 6, hence multiply the 3 by a 6, we get 3 into 6, which is $18. Okay, we already have our answer, 17.45 for 300 ml and $18 for 300 ml. Hence, option B in this case is a better choice, is a better value for money. I hope you have clarified any problems that you had in estimation and approximation. Stay tuned for more videos, and I am going to bring up all the topics that are difficult for you. Also, you can let me know personally if you want me to explain any of these NSM topics first. I can obviously do it for you. Thank you so much. Take care. Bye-bye.